Good, yeah. Alrighty, cool. Welcome, good morning everyone. So before we get started, who came to to my Docker intro on Azure, running Docker on Azure? Raise your hands. So not too many, okay, cool. And who is using Docker at the moment? Hands up. All right, so we've got a mix. All right, I've got a bunch of introductory Docker stuff. So I'll start by level setting, and then it is a level 400, so we're gonna go pretty deep, pretty quick. Also, who's hands up if you're not using Linux or not familiar with Linux? A couple. Okay, so feel free. It's a pretty small crowd. Raise your hand if I'm kind of glancing through some Linux stuff. If you've got some questions, just raise your hand or repeat the questions. So let's crack on. That was working. All right, so what we're going to cover today is Azure Container Service. So Azure Container Service is a really easy way to deploy the three most popular Docker orchestration engines onto Azure, those being Docker Swarm, Mesosphere DCOS, and Kubernetes. We are also going to plug in a Jenkins pipeline, and so basically show you how you can stand up Jenkins, how you can stand up Azure Container Service, how you can stand up Azure Container Registry as a private Docker registry, and then we're going to stitch them all together so we can build a Docker build pipeline. So about me, I work for Microsoft. I'm an Azure Technical Specialist. I specialise in open source software, and I cover customers and partners in Australia and New Zealand. I came from Red Hat, and I run the Kubernetes and Ansible meetups in Melbourne, so you can probably tell which is my favoured Docker orchestration engine of choice and what we'll be having a look at in today's session. Also a keen gamer. Very into RetroPie, so I've got my RetroPie arcade up there, and next project is shoving one into a NAS cartridge so I can take it around with me. Speaking of Raspberry Pis, very important you do your Ignite evals, but I've got my own little mini open source eval going on. So the open source team in Australia and New Zealand is pretty keen to get your feedback on what you like about running open source on Azure, what you don't like, what kind of features would be needed to run your business applications. So if you go to aka.ms/OSS feedback, you can fill out the survey there, and we'll be giving away some Raspberry Pis and some swag. So, alrighty, so Azure Container Services. So as I described in the intro, this is an easy way to deploy fully open source Docker orchestration engines on Azure, the three being Mesosphere DCOS, Docker Swarm, and Kubernetes. It's an extensible framework, so likely if there's other popular orchestration engines that pop up, we'll be able to support those as well. It's catered to handle, most of the clusters currently handle Linux, but in beta you can use Swarm and Kubernetes for Windows, and you can deploy on Azure and Azure Stack. So behind Azure Container Service is Azure Container Service Engine. So Azure Container Service Engine is a fully open source project. So this is the code that is used to take your parameters and build your Azure Container Service environment. So the reason we've done that is because we prescribe the kind of environments you can provision, so the number of masters you have, the base operating system it is. So I think Kubernetes is on Ubuntu 14.04, so if you want to use a different operating system, then this is where you would leverage the ACS Engine open source project to deploy your own customized version of Azure Container Service. Yeah, so configure it to your needs, you can contribute, and this is where you'll see new features land first. So if you want to try out Windows containers in Kubernetes clusters or Docker Swarm, you should have a look at the ACS engine project, you can create Azure Resource Manager templates with that capability at the moment. And you'll see some other features like some update scripts, which will allow you to do updates to your cluster and manage your cluster. So this is really what Azure Container Service is. So we've got Azure Container Service engine behind the back end. You'll go through the portal, through the command line, or through Azure Resource Manager. You feed the Azure Container Service resource provider details on what region you want, how many masters and nodes you want, what sizes. What it's going to do is it's basically going to create a customized Azure Resource Manager template and provision that environment. So the reason I highlight that is because it's not a managed service. What we're really doing is making it really easy for you to stand up these container environments on Azure, which are usually quite complex to stand up. And we're also doing a bunch of work in the Kubernetes, Docker, and Mesosphere open source projects themselves to make those platforms have really great native support for Azure. So let's start with the demo, and then we will have a look at, we'll kick off provisioning of some items, and then while that's happening in the background, we'll do a bit of a container intro and Docker intro. So this is what we're going to build. We are going to build a Azure Container Service cluster. We're going to be running Kubernetes. We're going to provision an Azure Container Registry, which is our private Docker registry. Important for your enterprise apps. You don't want to be pushing them up to Docker Hub and have them in the open. We're going to provision Jenkins, and then we're also going to wire up Operations Management Suite, which has a log analytics component to it. And we also have a container-specific solution as a part of OMS log analytics. So I'll configure that. And then we're going to set up a build pipeline, which is going to build a microservice application. It's a very simple application that's been made very complex by splitting out components just to demonstrate microservices. So we've got a bunch of different languages, Python, .NET, Node.js, and it's really just to highlight how you can use Docker as a standard packaging format and container orchestrators to manage these microservice applications regardless of what language you're packing inside the container. So let's cut over to the Azure portal. So I will just check that my stuff deleted, which it has, brilliant. So we'll provision a Jenkins server. This is click new in the portal, and then I can search for everything in the marketplace. We also have a containers section where you can get to a bunch of the container stuff directly. So the image that I'm going to use is this Jenkins Bitnami image. It's just a single node Jenkins server. So we're going to click that. Create. We're going to whack in a bunch of basic information. Provision it in Sydney. I'm going to choose a DS2 V2. So the DS series has solid state for the operating system disks, and the V2 is running on next-gen hardware. So you get a faster CPU than the standard DS series. So I'll select that one. Who's heard about managed disks? A couple, not many. Okay, so in short, if you don't use the previous way to provide your disk was use Azure storage accounts. Managing those storage accounts and your disks can get complex when you're scaling out. So we've introduced managed disks, which came out last week. It was supposed to go to public preview, but it's in such demand and it's so robust, we went GA straight away, which is really good. And so just make sure you click yes to manage disks, and then it just absolves storage account management away. You don't have to worry about it. And I think in the coming months we'll default that to yes, but at the moment it's still defaulted to no because it's a new feature. We'll also have to choose a virtual network to provision this Jenkins server to. Just going to do a final check on the ARM template to make sure everything's good. So that's provisioning. So the other thing I've already provisioned this morning is the Kubernetes cluster. So it takes about 5 or 10 minutes to provision. So I didn't want to tempt the demo gods with that one. So I've pre-provisioned it. So a couple of things going on here. First is I'm using Bash on Windows. Is anyone using that yet? Few, awesome. So Bash on Windows, you don't want to run production Linux workloads on Windows with Bash on Windows. It's designed as a developer experience. If you're familiar with Bash and Shell, then it just means that you can use all the commands that are familiar to you on Windows desktops as well. So I've got Bash on Windows installed. I've also got the Azure command line installed, and that's version 2. So you can grab that up on GitHub in the Azure repo /Azure-CLI. And this is the version 2 of the CLI. It's in Python. It's currently in beta, but it's pretty well developed in the beta phase. And the reason I'm using the CLI, so you can provision Azure Container Service from the portal, but you will need to provide an Azure Active Directory service principal, which is basically a service account that the Kubernetes cluster is going to use to have permissions to create objects in Azure, because we provide integration from the Kubernetes cluster to perform commands within Azure. So we take advantage of Azure networking, and the Kubernetes cluster can provision IPs and load balancers for your applications dynamically. So if you use the AZ CLI, you need to do 2 commands to provision. The first is AZ group create. So that's just to create an Azure Resource Manager resource group. We've called it Ignite Cube. We've provisioned it into Australia East, into the Sydney data center. And the second command is a little bit longer. We're triggering the Azure Container Service component of the Azure CLI. We're saying create a cluster, orchestrator type is Kubernetes. I've put my name, location, the resource group that we've just created. If you've got an existing resource group, you could just provision to that. I'll give the cluster a DNS prefix so I can access it from the interwebs. And here I'm specifying an admin user, which is just my name here, because it's going to automatically grab my SSH key from my environment. If you're not familiar with SSH with Linux, SSH is basically RDP for Linux. It allows you to securely connect to remote computers and execute commands. So it's going to grab my SSH key, and this is just going to specify my username for that SSH key, so we can then SSH to the cluster and execute commands. So that's going to go, and it's going to create that Azure Active Directory service principal for us, and then it's going to create the entire cluster. We'll go and have a look at what it created. All right, so this is all the resources it's created. It's created a bunch of agents where we'll run our application. It's created a master server which controls the cluster, and a bunch of other stuff. And just to kind of highlight how complicated this stuff can be to set up if you're not, if you're doing it yourself. I think there's in excess of, so almost 1,500 lines of JSON to configure and set up that cluster as is. So to do that yourself, pretty complex, and that's the beauty of Azure Container Service, is we're absolving all that complexity for you for those three Docker orchestration engines. So the third thing we need to provision is an Azure Container Registry. So we released this into public preview in November, so still in public preview. So we create one of these. Actually, DNS name doesn't like hyphens. So currently, public preview is only available in West US, Europe, South Central US, and East US. Choose West US because it's the closest. This is just the resource provider endpoint for the container registry service. You can still provision a storage account locally, so you can still store your images locally, but you'll be hitting the HTTPS endpoint in whichever location when you log into your registry. But you can still keep your data local. All right, so that's deploying. So that is all the components that we need to deploy. So while that's going, we'll kick through. So we already had a Kubernetes cluster, the ACS component. We've provisioned Jenkins, we've provisioned a registry, and they should be ready pretty quickly. And while that happens, we'll just do a kind of containers 101. So containers differ from virtual machines. The main difference is that in a virtual machine, we're virtualizing a physical server effectively. So we have a full operating system install. We install, for example, all your Java binaries and dependencies for your Java application, and then you're going to put your code on top. In containers, we're sharing the operating system. So we don't have a full operating system install. We're just installing your Java runtime and your application. So that means virtual machines, you're measuring gigabytes, and containers, you typically measure in megabytes. So much smaller units, and it means we can start up and scale them out quite quickly horizontally, so very good for web scale apps. The other cool thing is that we are packaging up your application with all its dependencies. So as a developer, I can define the exact dependencies that my application need, and I put them in my container, and then I give them to ops, and there's no discrepancy around what version of PHP is installed or what version of Java is installed. As a developer, I have full control of that. And then equally as an operator, regardless of whether I'm getting stuff from a Java team or a Node team or a .NET team, my unit of management is a Docker container. So it simplifies the management of different languages and frameworks for ops and makes it really easy for devs to package their application as is and have a lot of consistency between running on your laptop, pushing to test, pushing to production. It's a known state. It'll run exactly the same on all those environments. So that's really the main business benefits that you're getting from Docker containers, is that it provides consistency as you're moving your application through environments. So some semantics around Docker. So a Docker file is a text file. It's a YAML definition of how to build your container. So we'll have a look at one of those in a sec. And then a Docker file will define how to build your Docker image. So the Docker image is your packaged application. It's kind of a fancy tarball, a fancy zip bundle. And then a Docker container is the running instance of that image. So just some terminology differences there. And we now have support for containers on Windows since 2016, I think last November. So Docker containers, full GA support in Windows. We have, that support is backed by Docker Inc. So pretty robust support there, backed by both Microsoft and Docker Inc. But just wanted to highlight that you can't run Windows containers on Linux and you can't run Linux containers on Windows because in the virtual machines you have that whole OS that you're shipping around, but in containers we're sharing an OS, so we're relying on the kernel, whether that's the Linux kernel or the Windows kernel, to do a bunch of isolation stuff. So in Linux we've got a couple of different technologies to while we're sharing an OS, we still have security and isolation of resources. So we use control groups or C groups, which is something Google contributed a while back to the Linux kernel. And that allows us to provide resource controls, so we can still restrict the amount of memory or CPU a container has. And namespaces provide isolation. So container A can't speak to container B unless it's allowed, and it can't access the host system. So that provides our security and isolation to run multi-tenancy workloads on the same host. On the Windows kernel, we're using different technologies to deliver that because it's a different kernel, but the concepts are the same. We still have a notion of control groups and namespaces. We're just using different technologies under the hood in the Windows kernel to provide that. So while the differences in the kernel and the inability to swap out Linux and Windows containers across Linux and Windows hosts, you do have a lot of consistency in how you're going to manage containers. So regardless of whether it is a Linux container or a Windows container, as a developer or an operator, I still use the same Docker client, so Docker exe on Windows, so I can still do Docker run against any of those hosts using the same tools. And then when we abstract that another level and looking at Docker orchestrators like Kubernetes, that provides Kubernetes the same interface for those Docker containers. So then you can start having kind of mixed clusters of Linux and Windows hosts, and the orchestrator can handle intelligently where it's going to run the Windows containers and Linux containers. So good amount of consistency between the platforms despite their differences. So as we look at Azure for running containers, these are the more kind of Docker native solutions that we have on Azure. So at its simplest, you can run Docker in a virtual machine. You could install that yourself. You could use virtual machine extensions, which would automate the install of that for you. So we have a specific Docker extension on VM extensions. We can also use open source platform as a service projects or products from our partners, so OpenShift from Red Hat or Pivotal from Cloud Foundry. And then we've got Azure Container Service, which we're looking at more closely today. We've got a whole raft of other marketplace solutions in the Azure Marketplace. So we've got container optimized operating systems like CoreOS, Rancher. We just released ClearOS, which is an Intel optimized distribution. So we're the first cloud provider to have that, which has also got some container optimizations. But we also support Docker as a runtime in a bunch of other Azure compute services. So if you're looking to go and build a container native platform and you're looking to do Docker containers and pipelines, you're typically going to look at these products. But as an example, we've got Azure Batch, which also supports Docker. So you're not going to run probably microservice applications on Azure Batch, but you can use the same development tools and operational tools between your teams. So now your batch team can provide their applications as Docker format too. So different horses for courses, but consistency across the whole Azure compute platform to support Docker. All right, so let's go back to the demo and we'll see where we're at. All right, so our deployments are done. Now, so we've got our Ignite Cube, our Azure Container Service Cluster, we've got our Jenkins server, and we've got our private registry. So the first thing we want to do, is that font size okay for people at the back? Yeah, good. So you'll need a couple of things to manage your Kubernetes cluster. It has its own command line interface, kubectl or kubectl. You can go and get it, but we have made it super easy for you to install that via the CLI. By the way, I didn't mention the CLI is cross-platform, so I'm using it on Bash and Windows here, but you can also use it on Windows, you can also use it on Mac. So exact same commands, exact same experience. So this is the command you'd use, AZ, ACS for Azure Container Service, Kubernetes install CLI. I've already got it installed. The other thing you're going to need is the credentials to log into the cluster. So there's a bunch of key pairs on the cluster. Again, you could SSH and get them manually, but we make that easy for you with the get credentials command. So I'm saying get credentials from my Kubernetes cluster with the name Ignite Cube in the resource group Ignite Cube. And that's going to put it in the default location for kube control, which is in your user directory in, where is it, .cube. So this config file. So that's what it's pulled down from the cluster. So now we can run kube control, and it's got a bunch of different commands. It's quite a good command line tool. It's got a lot of documentation and help pointers throughout. So if you do a kube control describe -- help, whether you're on regardless of operating system, gives good description on the command, the different operators, but it also gives some example commands to use that. So good to get started. So when we provision a Kubernetes cluster, we don't expose it, the management to the internet. So you're going to have to proxy into the cluster, and kube control does that. So it uses that config file and the credentials we've got, and we do kube control proxy, and that's going to serve the management interface for our cluster on localhost port 8001. So if you go there and go /UI, we're going to get our dashboard. So in here we can see our Kubernetes cluster, we can see our nodes, etc. Now we want to set up. All right, so we've got to give it credentials to our registry. So we created that registry. It's a private registry, so you can't just push and pull to it without credentials. So we'll go into our registry here. So currently in preview, we create access keys for you, but coming is support for Azure Active Directory, so it will have Azure Active Directory support. So if we click enable, it's going to create a user for us. Copy that password. And we're going to create a secret on, it's not so secret because you've seen it, but we'll create a secret on the Kubernetes cluster. So for a new tab here. So this is creating a secret. It's called Docker Registry. Oh no, it's a secret for a Docker registry. It's called Ignite Registry. We have the username and the password to our server, and that's all we need. So I'll do that. It's created a secret in the cluster. We're going to attach that secret to our applications so they have permissions to pull the containers once we've built them. And then the next thing we need to do, I think we're almost up to, all right, so let's set up OMS. But first, let's have a quick look at a Docker file. So this is in Visual Studio Code, open source version of Visual Studio, runs on Windows, Linux and Mac, exact same experience. It's got native support for a bunch of open source languages, and we have a heap of different plugins, including plugins for Docker and for Kubernetes. So this is what a Docker file is. So I mentioned this is going to build our container. So this is an example, is going to pull down. So as a developer, I've said I want to pull down from node 5.11 is my starting point. I'm going to install NodeMon, so a couple of dependencies from my application, and then I'm going to add my application code from this directory. I'm going to expose port 80 on the container, and when I do a Docker run and start a container, I'm telling Docker to execute this command inside my container to start my application. So that's a Docker file. We also, before we kick off the Jenkins stuff, I've got this will be easier to explain with the documentation. All right, so on the doc site, which we just updated in December, so if you haven't been to the Azure documentation page, recommend going and have a look. It's much easier to find stuff. We've got a lot of updates to the actual documentation itself. But in the Azure Container Service documentation under Manage Kubernetes, we've got a monitoring section. So we give you details on how to plug in this instance, Kubernetes into Operations Management Suite or Datadog or Sysdig. These aren't Azure Container Service specific, so if you're deploying Kubernetes on-premise and you want to connect it to OMS, you can use the exact same instructions. So in here, it'll give you details in Operations Management Suite on where to get your workspace ID and primary key. And it also gives you a Kubernetes YAML definition to run the agent on your Kubernetes cluster. So what this is using is a Kubernetes concept called daemon set. And what daemon set allows you to do is say Kubernetes, because Kubernetes is a declarative environment, as most of these orchestrators are. So say Kubernetes, I want to run one of these container, and I want you to run it on every host in my cluster. So perfect use case is for logging and monitoring. So that's what we're leveraging to deploy our Operations Management Suite container. So we are basically telling Kubernetes, run this OMS container under the Microsoft repository on Docker Hub and run one of them on every host. We're giving it escalated privileges. So I mentioned before that we've got user namespaces, so container A can't see B and it can't see the host. So what we're doing here is we're escalating the privileges of the container. We're saying for this container, you let it look at other containers in the host, and then it's using the Docker engine to basically ingest all the logs from the containers in the host and then throw them out to OMS, and it's going to throw them out to our workspace here with our key. So that's the file that I had open in code. So let's launch that. All right, so that's that YAML definition on the docs page, but with my credentials for my Operations Management Suite workspace in there. So if we go back to the cluster, we should now see some activity here. So we've got our daemon sets kicking off. So we've got 4 nodes in the cluster, so it's spinning up one container on each node for us. Next thing is setting up Jenkins. So before I get too into that, so all the code I'm going to be deploying, including the scripts I'm running, are all in my repository up on GitHub. So /me Ken Thompson example voting app. I will be adding my instructions to run the app after the session. So if you want to go and do this demo, you can go here and grab the code. So in here I've got some things just to speed up the demo. So there's a couple of scripts that I'm using. So first one is not a script, but we're using SCP. So SCP allows us to send files over SSH. So I'm saying send that kube config that I got with the AZ/ACS get credentials flag. Send that file, log in as K Thompson, that was the admin user I specified, my cluster, which is Ignite Jenkins Australia East Cloud App, blah, 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 into this directory, home K Thompson config. That wasn't supposed to happen. Let's see if I... I know. All right, so I'm trying to send it to my Jenkins server, and my Jenkins server doesn't provision with a DNS name. So if we go into our Jenkins box here, grab our virtual machine, for the IP. All right, so I'll click on the IP. I could just go directly to the IP, but I'm going to add in a DNS name for this because that's what all my scripts are referencing. So I'll just add in ignite-jenkins. It's going to go and validate that is available. All right. Take 2. Now, because I've done this demo a couple of times, I've already got a reference to that host name on my computer, so I just have to remove that so it's got the right IP now. Let's get rid of all that. All right. Take 4. All right, so that's copied the file up to our Jenkins server. So it's copied the Kubernetes configuration file to our Jenkins server. So the Jenkins server from Bitnami, really easy way to get started. They already have the Docker engine and Docker daemon installed, but it's not enabled for the user Tomcat, and the user Tomcat is what launches, what Jenkins runs as. So we need to do a couple of things. We need to give the Tomcat user on the Jenkins box permission to run Docker. We also need to install the kube control command line because we're going to use Jenkins to deploy to our Kubernetes cluster. So we're going to run the script I've got up in GitHub. So what this is doing is I'm saying via SSH, connect to my Ignite Jenkins box and run this command. So I'm just pulling down my shell script and it's going to run it, and then it's going to output what it's doing on my local PC here. So firstly, it's going to go pull down the kube control command line from GitHub. It's pretty quick. It's going to put it in the right directory, make it executable, and then here's the command to add the Tomcat user to the Docker group so we can execute Docker commands, and then that's it. So the Jenkins server is now configured. So now we can go to the Jenkins box. So let's go to Ignite Jenkins. All right, so the Bitnami image, by default, will create a unique password when you provision it. The way you get the unique password is we go back to the virtual machine here, our Ignite Jenkins virtual machine. So we've got a bunch of native support for Linux on Azure. One of the things that we do, as well as being able to reset your password, SSH key and config, is we've got this boot diagnostics section. So if you've got issues with hard drives mounting, etc., you can grab a screen grab from when your VM's booted, because you can't get direct console access, but we do give you a screen grab of the console when it boots in case there's issues. And we also grab the boot logs and output them into the console. And what Bitnami are doing, they provision Jenkins, and then they'll create a unique user with a user with the username user, and then they'll create a unique password, and they're outputting that into this diagnostic logs. So we just have to go in here to grab it if it loads. Let's try and get it in Edge. That's not very... useful at all. All right, let's change track and we'll go to a different cluster. What we got? So here's another cluster that I created for my other session. So let's pretend this is a brand new server. So what we'll do, the first things you're going to have to do in Jenkins to get the demo working is you're going to have to install some plugins. So you'll need the Docker pipeline plugin, because what we're going to do in Jenkins is build some pipelines. So it needs the plugin for the Docker support in pipelines. We're also going to have a look at the new version of the Jenkins console, which is designed specifically around pipelines, which is called Blue Ocean, which is in beta. So the easiest way to install everything that you need is we come into Manage Plugins, and then I've already got Blue Ocean installed, but what you would want to do if you're starting from scratch is go to Available and just search for Blue Ocean. And there'll be the Blue Ocean beta, which I've got here. you just install that, and that'll grab all the dependencies for Blue Ocean, all the dependencies for pipeline builds, including the Docker build. So it'll give you the nice new portal and the Docker plugin that you'll need to get started. Second thing you're going to need to do is create some credentials. So we're going to need credentials for our GitHub. So the other thing, so we have two-factor authentication enabled for our Microsoft GitHub accounts. So if you have two-factor auth enabled for your GitHub, you're going to have to create a token because Jenkins doesn't understand that it needs to wait for a SMS confirmation code. So you need to create a personal access token, which is basically a unique RBAC token password. So you just want to generate a new token. Log in. Give it a name, and it'll just need repo access and access for hooks, because what we want to do is we want the Jenkins server to watch GitHub, and every time we push a change to GitHub, we want it to rebuild our application and send it through our continuous integration pipeline. Which one are we at? This one. All right, so you'll need that, and you'll also need the private login. So I'm going to have to update this one with the registry password that we had. So then this will give Jenkins the ability to build those Docker images and push them to our private registry. We've already given permissions to Kubernetes to pull those built Docker images, and this is going to add it as a secret as well in Jenkins. All right, and then we're going to create our pipeline. So we're going to create a pipeline, let's call it backup pipeline. Hopefully I haven't done anything on this server that stops it working. So you're going to need to pull the app code onto that server. So in the repo, I've got a Jenkins file. So all we need to do is point it to this GitHub repository, and then it's going to look automatically for this Jenkins file in the base directory, and then it's got all the code to create my pipeline and execute the steps. So this is so Jenkins used Groovy as a formatting language to build your pipelines. So what this is telling is for this job, we want to pull the code from Meekan Thompson, example voting out. And then I've got a bunch of stages. So we've got like a build stage, a deployment stage, and a fake tests stage. We're going to use our Ignite Microsoft Azure Container Registry, our private registry. We're going to use that private login credentials that we just passed in. And then in parallel, it's going to build 3 different containers at the same time. So it's going to build our worker app, which is in .NET, our result app, which is in, I think, Node, and the vote app in Python. It's going to push those images up to our registry, and then it's going to execute some Kubernetes commands to deploy that to the cluster. So if you were doing a proper pipeline, you would label your containers. At the moment, I'm just like pushing up and labeling them latest. So Kubernetes doesn't accept that as a valid deployment principle, and good reason. So it won't restart the containers. So what I'm doing here is I'm saying delete all my voting containers and my results containers when you push this new code. And then because Kubernetes is declarative, it's going to notice that I need 4 of these containers, and I haven't got 4, so I'm going to create new ones. So it's just a kind of bit of a hack workaround to get it to update with the new code when we're pushing code. Yeah, so that's all we need to do for that. So we just go back here and get the Git link. Alright, so all we need to do in here is we want to use the GitHub hook trigger. So anytime we push code to GitHub, I want it to trigger this pipeline. And then you could do a pipeline script, but because it's in the same repo, I've got that Jenkins file in the base repository. We're going to do pull from source code management, choose Git, and put our repo URL in there. And we'll have our GitHub credentials. All right. So that means I'm going to have to log into my old cluster. So Bash on Windows has its own basically file system. So I've got a separate configuration files on my Windows file system, which is for my old cluster. So we'll kill this proxy. And all right, so this is a different cluster. We're not using the Ignite Cube cluster anymore. I'm going to my backup cluster, which is Aussie Cube Management. So again, I'll just run a kube control proxy, and then that is going to take me to our cluster. So on this cluster, I've already got an existing deployment. So let's nuke that. So we'll go kube control, delete deployments all. And that'll go and delete all those deployments so we can watch it provision from scratch. So we can see some pods are starting to reduce. Still got the results app there, which should now be gone. Slowly. Alrighty, so the cluster's in the process of cleaning up. So if we go back to that one, so we've got our Jenkins server set up. We've got kube control installed on it. We've got our credentials for our cluster. We've got the Kubernetes cluster stood up. We've got Azure Container Registry. I've already hooked this cluster up to Operations Management Suite as well. And so now we've got that definition of all those applications is in my GitHub repository. So all we're going to do now, and touch wood, I've not missed anything by swapping between environments. So the first time this will build, it'll take about 2.5 minutes, I think. So let's go back. We've got our new pipeline here. And we can see it's building from this specific commit. And these are our 3 parallel builds that it's doing. Oh, thank you. That would help. All right, so here we go. So it's kicked off the build. It's executing all the Docker builds for us in parallel, and then it's going to push them all to the registry. Might even be quicker on this one. All right, so while that's doing that, let's go and have a look at our application. All right, so the app has basically got two things that you can muck around with. There's the front end, the voting app, and the results application that will see the results. So it's forked from the Docker example voting app. By default, that's you vote on cats and dogs. So let's change that to beer versus pizza. So just change a couple of spots. We'll change the options here, our voting options. Save that. And in here, this is in the voting app. So the voting app's in Python, beer and pizza. And I'll wait to push that. We'll just see if this is finished building yet, so we can watch it kick off the pipeline dynamically. So while that's doing that, let's have a look at, so the other way you can provision the Azure Container Service is via the portal. So if we go here, I've got container services here. If you can't see it, you just scroll down to the bottom and click the More button, and you can search across all the Azure services. This really not loving life, is it? So this is the other way to provision a cluster. Just click Add, then you'll choose the enter in your username, your SSH key, what you want to call the resource group. So via here it's going to create the resource group for us, or we could, I don't know, it has to be in a new resource group, and then we can choose our location. Then you're going to get your choice of DCOS, Kubernetes or Swarm. So if we choose Kubernetes, it's one that's going to prompt you for the service principal ID and secret. So you'll need to create that either via the AZ command line, or you need to go to the old Azure portal, so that where you manage Azure Active Directory. Alrighty. Cool. So that has provisioned our app in the existing cats and dogs format. So we should see, go in deployments. So we're still provisioning the results and voting app, but the other ones are stood up already. The other thing we'll have a look at, hopefully it's provisioned already, which it has, is its provisioned services. So while these are microservices, we can scale them out all independently. And with Kubernetes, typically you need to do an overlay network to provide networking between containers. But we're taking advantage of, we've already got a virtual network on Azure, it's called Azure. So we're using that, and we are actually plugging directly into Azure Load Balancer and Azure to create a public IP address, and then create a load balancer across all those containers for us. So what we can then do is we'll grab the IPs, and we've got Azure DNS, which came out last year if you haven't heard of that support, so we can host DNS names in here now directly. And which one was this? the result app. I think that's the same IP. All right, excellent. Because I'm using my same cluster, the IPs are the same. So if you want to have a vote, you can go to vote.onazure.io. And hopefully that's going to... You know what? In the cluster swap, I haven't put the credentials for that secret. So it's not able to pull our voting app. So let's go here and we'll go... I think I might have to delete that secret. Control. Delete secret. All right, so these were getting image pull errors because it was trying to go to my private registry despite I've coded in the URL. I've created a brand new registry, so it's got new credentials, so it didn't have permissions to pull the image. So I've updated those, so hopefully that should start pulling down now. Yep, there we go, so we've got a couple of containers. So now we should be able to hit the vote app and the results app. Results app is up. All right, here we go. Should be coming online shortly. There we go. All right, so I've got our application up, but this is now the cats versus dogs one. So we can vote in here and it'll update cats. See votes coming in already. It's going to dynamically change. So what this is doing is, so we're going through the voting process. It's a very overcomplicated, simple application. It puts it into an in-memory cache because we're getting such high traffic. We've got a worker service that is watching that cache and then pulling the results and putting them into a Postgres database. And then our Node.js app is just pulling the results from the database and displaying them. So we've got 18 votes already. So let's push that code to update to beer and pizza. So in VS Code, we've got native support for things like Docker. We've even got a Kubernetes extension, so you don't have to go into the command line to run your Kubernetes stuff. You can run it here. And we're also able to run a terminal in the screen, so you can be working on code and have a terminal view just down here as well. You can drop straight into Bash on Windows or PowerShell or CMD. And the other thing we've got is native Git integration. So we can do update pizza and beer as our commit message. We'll commit those changes and then push them up to GitHub. And that should push them up pretty quickly because they're not big changes. If we go back to our pipeline view, hopefully I reset that up so to watch the hook. Which I may not have done. There's another, there's another credentials you have to put in the main Jenkins area. So let's just kick it off manually. So if I did not screw my demo environments up and did that properly, that would automatically trigger a new build in the pipeline, so we can just manually kick it off now. So you see the old build, or the first build, took a bit over 4.5 minutes. But because it was the first build, it was pulling down all those Docker images, it was pulling down on my source code. So now that's already on my Jenkins server, so this one you'll see is pretty snappy. It's already rebuilt the containers, pushed them up, redeployed it, and doing an arbitrary smoke test. So we should start to see these vote containers change. So we can see now they're all scheduled. So we removed the old ones. I did my hack workaround to get rid of my old containers, and it's forcing it to update to new ones. Then if we refresh here, we're updated to beer and pizza. But I didn't, you'll see that I didn't, and someone's load testing, nice. I didn't update the database. So we are, all we've done is update the front end and the back end, and I've left my database. So, well, I think there's load testing wars by the looks of it. All right, so that's pretty much it. So let's see what we've got left to cover. So just before we wrap up, just wanted to quickly give you an update on what our open source strategy is. So ultimately it's around choice and flexibility. So very focused on providing open source on Azure and making Azure a really great place to run open source software. Azure Container Service is a really great example of that because that is a fully open source stack end to end. It's the exact same Kubernetes distribution or Docker Swarm or Mesosphere that you can run on premise or on another cloud. So if you're looking for hybrid cloud, multi-cloud flexibility, really good story there. But not only do we just want to let you run the open source framework, we want to make Azure the best place to run that framework. So that's where we're doing stuff like integration into Azure networking, Azure storage, and automating the deployment of that environment for you to make it super easy to stand up and get going. So 4 kind of key areas to how we're approaching that. So we're enabling open source in Linux virtual machines. We also support a bunch of open source languages in our platform as a service offerings. So support for things like PHP, Node.js, Java in Azure App Service. And we have integrated solutions like Azure Container Service. We also have HD Insights, which is Hadoop, basically platform as a service. That's a fully managed PaaS offering. And we've got Azure Redis Cache, which provides you Redis cluster. So I could have took advantage of that rather than deploying the container. We're also releasing a lot of key Microsoft technologies into open source domains. So you would have heard about PowerShell. So now you can run PowerShell on Mac, Linux, and Windows. And the same core, so a lot of flexibility to use PowerShell, powerful tools to control Azure and other resources from the desktop of your choice. And things like .NET Core as well. And then we're participating in a bunch of projects, so Linux kernel, Hadoop, we do a lot of work there. We're doing a lot of work in projects like FluentD, so we had a look at deploying the Operations Management Suite container, and that I didn't show you, so I'll bring that up in a sec. That is using FluentD as the OMS agent, which is an open source agent, pretty popular in Elastic search deployments. And lastly, the distributions that we support on Azure are pretty much every major distribution that you're familiar with, so Red Hat Linux, SUSE, Ubuntu, and also container-specific ones like CoreOS and Rancher. So before we wrap up, I will just quickly show you that the Operations Management Suite portal, where we're grabbing those logs off the Kubernetes cluster. So if you go into Log Analytics in the portal, I've got our workspace here. open that up. So in here, I've already set up the container solution. We've also got an update management solution, which will have a look at both Linux and Windows VMs and check for out-of-date updates. And then you can also use it to automatically go and remediate those servers and update them. But we have a look at the container solution. We've got a nice dashboard of, hey, there you can see my my pull errors because I didn't have my secret starting to pop up on the OMS dashboard. So you're getting real-time insights into the cluster. We can do a lot of more complicated log search, but this just provides a nice aggregated view of it. And then I could set, for example, that error on the image pool. I could set an alert to email me or trigger a ticket in my monitoring, my ticketing system, etc. So pretty cool solution, really easy to get set up using the documentation. And with that, just sum up on what we covered, which was how to look at Azure Container Service, so easy way to deploy Docker Swarm, Mesosphere, DCOS, or Kubernetes on Azure. And we also had a look at deploying Jenkins as a CI/CD tool chain, and then creating a CI/CD pipeline that integrates Azure Container Service, Jenkins, Azure Container Registry. And that's me. So any questions? Yeah.
How does ACS handle updates to Kubernetes and the nodes?
So at the moment it doesn't. So it'll create that ARM template and so I'll repeat the question for the recording. The question was how does ACS handle updates of the orchestrators like Kubernetes? So it doesn't update them. They're not managed. It will create the Azure Resource Manager template and it'll deploy their cluster, and then it's effectively infrastructure as a service which you have to manage. But if you have a look at the ACS engine open source project behind Container Service, you'll start to see some pull requests for patch and update scripts. So there is stuff there to help that, and I imagine at some point when that's tested, it'll be in the product. Yeah. Yep.
How come it hasn't been implemented as a platform as a service?
Yeah. So. Yeah. Yep. So. We took the strategy with the Docker container. So the question was, why isn't ACS a platform as a service offering, so fully managed offering? So Docker's pretty new, it's pretty popular, but being new, it's evolving at a very rapid pace, and there's no winning orchestrator yet in the marketplace. It's very hotly contested between Docker, Kubernetes, Mesosphere. There's a stack of others who are also competing. So we said it's moving pretty fast. And to make a bet on what the winning one is. So basically pick the most popular ones and make them available. But in that, because they're moving so fast, it is hard to provide update management around those evolving ecosystems. So that's why we're making ACS engine open source, and we're providing a more, restricted, well not restricted, but defined Azure Container Service stamp that can be automated and deployed. So it's an evolving ecosystem, so that's kind of the approach there. Yep.
Is there any reason why you didn't deploy Jenkins as a container?
Any reason I didn't deploy Jenkins as a container? No. I just wanted to highlight that you can get a bunch of open source solutions in the marketplace as well. So you could definitely deploy Jenkins as a container on the cluster itself. And there's documentation on that as well on the Kubernetes site. Could have done it a bunch of ways, but just wanted to show that we can deploy container solutions. We can also deploy packaged virtual machine solutions from partners like Bitnami from the marketplace, and we can easily integrate them. Alrighty, thanks everyone. Make sure to fill out your evals. Cheers.